Let f of x be a function with a domain between 0 and infinity and a range between negative infinity to 0. Oh, I hate this already. So let's draw a picture. And we'll let f of x be red. Domain is 0 to infinity, which means to the right of the y-axis, and the range is negative infinity to 0, which means up to the x-axis, so smiley face. There you are. Oh, not bad. You got a weird-looking eye there, but I like him. He's my friend. He's the only friend I have. Find the domain and range for g when g is 4 times f of x, which means it's super stretched out, minus 2, and then the x is negative. Ooh. All right. So first thing we need to look at when the x is negative means we take this guy, flip him left to right. Okay? That is called a horizontal shift. When you negative x inside, you just flip it left to right. It's a mirror image left to right, as opposed to flipping up and down. So this is a mirror image. So of course, if you had like an eye patch, the eye patch would live here, but that doesn't really matter in this context. If you multiply it by 4, you are stretching him up, okay? So he's actually going to go down here a little bit. And if you minus 2, he's going to, oh boy, he's going to go down a bunch. So let's move this poor guy's face. Okay. And then the extras, and then the extras, and then the extras. So what we have is basically this green guy lives between negative infinity to 0 on the domain. So not you, but these two guys are still good. So the range is where it gets iffy. The domain has to peak out at 0. So if I plug in 0 for x, nice if I had a marker. If I plug in 0 for x and I multiply 4 to 0 and then subtract 2, that becomes 0 minus 2. That becomes minus 2. So my range starts at negative 2 and goes down forever. And the only one that has that as an option is C. So a very tricky problem. My suggestion is if you're like, I really hate this and I hate it a lot, then try plugging in domain values and see what happens to your answer and when you plug it in here and take it from there. Kind of an iffy problem. Don't like it.